Hi, today we're going to conquer the representation of binary numbers or negative binary numbers using sign and magnitude. But before we start, can I ask that you click on the like and subscribe button below so that you don't miss out on any of our videos. Also, don't forget to click on the link below so that you can access worksheets to practice sign and magnitude representation. Okay, so let's make a start. So we're looking at sign and magnitude in terms of representing negative numbers. But just to recap, here you can see the 8 columns for potentially representing positive numbers using 8 bits. The most significant bit being 128. Now, sign and magnitude is one way of representing negative numbers. So what happens is that the most significant bit gets replaced, okay, with the sign. The rest of it is known as the magnitude, okay? So just to refresh ourselves a little bit, before I change the most significant bit to the sign, if I had ones all the way through, that would give us a maximum positive number of 255. 128 plus 64 plus 32, 16, 8, 4, 2 and 1. That would give us 255. Now we're going to get rid of, and I've mentioned this for a reason, because when we get rid of that most significant bit and we put a sign there, suddenly we've slashed the number in half. So the maximum that you could represent here, 64 plus 32 plus 16 is 127 basically. So there is a downside to this. However, we'll look at 2's complement, which is another technique in the next video, but we'll focus on this even though we can see that there is a slight disadvantage when you remove the most significant bit. So we've got a plus or minus, so that represents the sign. The rest of this is the magnitude, in other words, the number. So if I wanted to represent a negative number, I'd have to put a 1 there, and then the rest of it is just a simple magnitude. Right, just grab my notes. Okay, so let's start off. Now, if we were representing, let's say, minus 22, all you need to do is put a 1 beneath the sign, and 22 is then going to be represented just like you would normally do with a unsigned number. So 64 doesn't go into 22, 32 doesn't go into the 22, but 16 does. Okay, that leaves us with a difference of 4 plus a 2, 6. So 6 we can make up with a 4 and a 2. There you go. So minus 16 plus 4 is 20, plus the 2 is 22. Minus 22. Let's do another one. Minus 71. Okay, so as you are now becoming familiar, 1 for the negative. And if we're wanting to represent 71, that's going to be 64 plus 32. No, minus. Oh, mistake there. 64, 32, if we added 32, that would obviously take us over. If we added 16, that will take us over as well. It is minus 71. So plus, we don't need 8, plus 4, that gives us 68. Plus the 2 gives you 70, plus the 1 gives you 71. So that's minus 71. Right, let's have a look at another one. What if we had to represent minus 127? Okay, that shouldn't be too tricky because you've got 1 for the sign or the negative, and the rest, 64 plus 32 plus 16 plus 8 plus 4, 2 and 1, should give you minus 127. Let's do one more. Minus 50. Okay, so again, sign, it's got to be a 1 for the negative. And now we're going to represent 50. So that would be 0. 32 goes into 50. Plus 16. So that gives us 48. plus the 2 will give us 50, and then you put the zeros in. Now, that's straightforward when you are representing negative numbers up to minus 127. However, if you were to be asked to represent, let's say, minus 60, that would be a little bit of a problem. So what you would need to think about then is adding another column. Similar to how we started off with unsigned binary, where if the number is larger than 255, you'd add another column. Here with sign and magnitude, you'd add another column. So you've got the 128 back, but 256 would be the next column, but obviously as this is sign and magnitude, that most significant bit is removed and you end up with your sign. So 160 would be, or minus 160 would be 1 for the negative, and then you'd have 128, which goes into the minus 160, plus 32. And I think that's 20, 30, 40. Yeah, that would give us 160, or minus 160. There you go. So 1 for the sign, and 128 plus a 32 gives you 160. So you've got your minus 160. And that's really important because at A level, you would expect them to give you questions that might potentially throw you off. And this is a question where normally you would be practicing using 8 bits, but if you remember what I said earlier with minus 127 being the cutoff point, if you do need to represent a number that goes beyond that, you do need to add another column. So that's sign and magnitude. Next video will be on representing negative numbers using 2's complement. One other thing before I leave you to it, sign and magnitude is a method that is not normally used for storing negative numbers on the computer because of the fact that we're using 2 parts. You've got the sign and you've got the magnitude. Now, calculations on the computer become far more difficult because you've got 2 parts to the binary number. One part is the sign, the rest is the magnitude, making calculations very, very difficult. And if you are asked in an exam as to why, or the disadvantage, or why sign and magnitude is rarely used when it comes to calculations, the reason is that the binary number is made up of 2 parts, the sign and the magnitude, making calculations far more difficult. That's it for today.